Hello everyone, welcome to this part of the video where we are given the diagram. And in this diagram, we are given the dimensions of the height of this pole, 900 cm, perpendicular to the, this is an important clue, perpendicular to the ground. So let's zoom into this. Perpendicular means that there is a right angle here. And so straight away, Pythagoras theorem comes into play. A string of colored flags is tied tightly from the top of the pole to a point on the ground. And they do give us how many meters away from the pole? 5.5. Notice all the dimensions are given in meter. So instinctively, I would convert 900 cm to 9 meter. Yeah? So now, part A. We will need to find this length of the string in meters. Alright. And so using Pythagoras theorem, where it states that, given this is A, B and C, C square is equals to A square plus B square. So I would then have the length of this string of color flags BC. So therefore my C square is equals to 9 meter square plus 5.5 meter square. This will give me a value of 111.25, and therefore my C is equals to the square root of this value. I'm going to leave my answer to a 6 significant figures first. Followed by 3 sig-fig answer, 10.5 meter. Now, for the cost of this flag, they do give me how much for each meter? $5.50, meaning that for each meter, each 1 meter is $5.50. Now, I have this 10.5475 meter. How much would that cost? So my cost will be equals to 10.5475. Notice I did not use the 10.5 meter. This is because I would want to have my answer to be as accurate as possible. So I would use the value of a higher accuracy. And this will give me a value of $58.01125. Since the answer is given in dollars, we would round it to the nearest cents. $58.01. Alright, that would be the end of this particular problem. And let's move on to the next question. Hello everyone, welcome to this part of the video where we are given this problem. Jane claimed that there is this triangle that is right angle. Is her claim correct? Well, we could tap on our knowledge of Pythagoras theorem, which states that the sum of, if it is a right angle triangle, if it is, then the sum of the squares of the two sides that make the right angle will be equal to the square of the hypotenuse. So, because we would not know, this will be the working. Alright, first we check what is the square of the hypotenuse. In this case, it is this length, AB. So AB square is 11 square, and let's see what number this number is. It's 121. Next, we then check the sum of these two sides that make the right angle, if it is a right angle triangle. If not, then the angle is not right angle, alright? So BC square plus AC square is my 6 square plus 9 square. And I get 117. Now, when I compare, they do not equal to each other. And because they do not equal to each other, do you think this is a right angle triangle now? Yep, it is not. So I have successfully proven it, that her claim is wrong. Okay, her claim is wrong. As AB square does not equal to BC square plus AC square. My working has shown that by the converse of Pythagoras theorem. This triangle ABC in this case is not a right angle. It's not right angle, or it's not a right angle triangle. So the key words in this case here is by the converse of Pythagoras theorem. This must be written down. And notice my working don't start off with AB square equals to BC square plus AC square. No, we do it separately. Alright, and that will sum up this particular problem. Let's move on to the next question. Hello everyone, welcome to this part of the problem where we are given the sum of interior angles, and straight away this is something that we need to remember. The sum of interior angles for all polygons is equals to n minus 2 times 180 degrees, or this can also be written as 180 times n minus 2. So with that in mind, now that I know my 1980 as the sum of the interior angles, and n-gon means this is a polygon with n number of sides. So I can then equate this with 1980. So my n minus 2 will be equals to 1980 divided by 180. So n minus 2 is equals to 11, and therefore n will be equals to What should I do to this minus 2? Yep, I'm going to plus 2 on both sides. So final answer, n is equals to 13. Next part involves a regular n-sided polygon. The word n regular means equal sides and equal angles, be it exterior or interior. So now I know all the exterior angle is 40 degrees, and this is an important property. The sum of all exterior angles is equal to this 360 degrees. So how many 40 degrees are there? You catch it already, yeah? So n, which is the number of sides, is simply 360 divided by 40 degrees. This will give me 9. 40 degrees, by extension, 9 sides. With that, we have come to the end of this part of the problem, and let's move on to the next question. Hello everyone, welcome to this part of the video where we are exploring this problem, where we are given a trapezium ABCD. X is on the line BC such that we have a right angle triangle here. So to find AX, right, there's this right angle triangle. So this means that I could apply my Pythagoras theorem, which states that, well, my a square plus b square is equals to my c square, yeah? So in this case here, I would have my ax square plus 8 square is equals to 17 square. So I will need to minus away my 8 square on both sides. This will actually give me a value of 225. So that my final answer, AX will be the square root of 225, which is equals to 15 cm. And because now I know this is 15, a trapezium, when we need to find the area, I would then need to look at two things, which will be the sum of the parallel side and my height, 15. Okay, so this 15 will become my height of the trapezium. So with that in mind, I could then zoom in. So the area required will then be equals to half times the sum of the parallel lines times the height of the trapezium. And going back to this, we will have the height as 15. And this one, I just need to sum them out and I will get my answer. This one will be 15 plus 29. I just need to bracket them, times 15. And so the answer would then be 330 cm square. And we have come to the end of this part of the problem. Let's move on to the next question. Alright, for this problem, we are given a triangle that is mapped into another triangle by an enlargement. Okay, I'm going to zoom in now. Enlargement, that means become bigger. So my red color triangle becomes a bigger triangle by an enlargement, and the enlargement is of scale factor k. So what is this scale factor? Meaning how many times it has become larger. Well, if you cannot see clearly, usually I recommend my students to or my viewers to just draw out another triangle so that we can see that this is 2 and this whole part is 10. So I can then tap on this to find my scale factor. So k, which is the scale factor, is simply equals to, we always divide by original once we have identified the corresponding sides. Yeah, so in this case we divide by 2, 10 divided by 2. Okay, we always divide by the original. So k equals to 5. The triangle is 5 times larger. And with that, I will then be able to get to the next part, which require us to find DE, because I can then see my corresponding side, 20 here, and 20 is 5 times larger than DE. So what do you think the length of DE is? Yes, I'm going to divide by 5. Four cm. Alright, when we have come to the end of this part of the problem, let's move on to the next question. Hello everyone, welcome to this problem where we are given a scale 5 cm on a map. A represents 8 kilometers. So first part A would then be for us to write this in this form. And when they require us to write the scale in this form, do take note both will be in centimeters. Okay, so 1 represents the map, 1, and the other represents the actual. So now I start off with 5 cm representing 8 kilometer, and because I need my 1, so I will divide by 1 first, divide by 5, sorry, that will give me 1. I do the same at the other side to give me 1.6 kilometer. So basically I get my 1 already, right? So now it's for us to convert 1.6 kilometer into cm. And if you are not very good at converting straight, I usually recommend you to do it in stages. Kilometer to meter is multiplied by 1000. So this transition requires us to multiply by 1000, followed by cm. So now I know it's 160,000. No units. Alright. Do take note, the final answer here, we do not need to write down the units. Okay, so for this answer here, no need to write units. It is a ratio. Okay. Part B. We are now given that the length on the map is 7.2 cm. What then is the actual length in meters? And now, for this particular question, I would actually use this because it is essentially the same map scale. Yeah. So now that I know on the map 1 cm represents 1.6 kilometer, then I will be able to get this 7.2 cm pretty easily by multiplying by 7.2 to give me 11.52 kilometer. And do take note, the answer they would require us to write in meters. So I would then simply convert this to meter by multiplying by 1000. Alright, and for the last part of this question, where we are given an area now, and we need to find the actual area, then we will need, since we are dealing with area, we will need area scale, the scale for the area. Okay, and how do we get that? We will start off with 1 cm representing 1.6 kilometer. I usually like to start off with this. And to get an area scale, I need a square, right? I will then square the scale. 1 cm square is 1 times 1, 1. Now cm is square. 1.6 kilometer square is 2.56 kilometer square. So now I can easily find my 52 cm square simply by multiplying by 52. And I will get 133.12 kilometer square. And so, the key to this particular question is, for part C is really I need to get this area scale. If not, I cannot proceed. Yeah? And the special tip here is to always use the scale that will help us. Notice I did not start off with 5 cm to 8 kilometer for my part B and part C. I always fall back on the scale that will be easy for us to use. In this case, 1 cm to 1.6 kilometer. Alright, let's move on to the next question. Hello everyone, welcome to this part of the video where we are given this pyramid. Ooh, the height is given and the square base. Well, we need to find this lance height that require us to focus on this particular triangle. What do you think is this length here? It is at the middle, right? So if the square is 6, length of the square is 6 cm, this will be, yes, 3. And so Just for simplicity, I'm going to just draw this right angle triangle, and I am going to make this line height L. Right angle, I have 12 and 3 now. So how do you think we should find this line height L? Yes, we are going to apply Pythagoras theorem, yeah? So by Pythagoras theorem, L square will be equals to 12 square plus 3 square to give me 153. And so my L will be equals to the square root of 153, which would be 12.3693 to 6 significant figures, followed by 3 sig fig, 12.4. Hence, we are going to find the total surface area of this whole pyramid. And at this point, right, do take note, if I were to draw this, the net of this pyramid, then I will have a square base, and 4 triangles that are the same. And I also know that the height of the triangle already, I also know the base of the triangle is 6. So with this, I would then be able to get my total surface area pretty easily. It is simply the half times base times height This is for the one triangle. How many are there? 4 of them. Then I will have to add on the square base, which is 6 times 6. So this will give me a value of 184.432 to 6s. F significant figure followed by 184. As for the volume of a pyramid is 1/3 times base area times height of the pyramid. Okay, height of pyramid I cannot emphasize further. So I will have 1/3 multiplied by base area is the square and multiplied by the height of the pyramid, 12. To give me 144 cm cube. And we have come to the end of this solution for this problem. And let's move on to the next question. Hello everyone, welcome to this part of the problem where we are given this manufacturer producing a cone-shaped chocolate, height 8 cm, slant height 10 cm. So I'm going to zoom in now. Calculate the radius of this particular chocolate. Now it will be good for us to see that there is actually a right angle triangle, right? And therefore I could apply my Pythagoras theorem easily. Radius is OB, yeah? So OB square plus 8 square is equals to 10 square. So therefore I will be able to get, what do you think we should do to this x square? Yep, we are going to minus away the x8 square on both sides. And therefore OB is equals to the square root of 36, in this case 6 cm. And from here, now that I know the radius, then we could find the total surface area in terms of pi. Oh, they want us to live in terms of pi. So the total surface area would then be equals to two things. The first thing is this circle. Circle will be equals to pi r square. We got our r already, 6. From the previous part. Next, we will need the curved surface area, which is at the top. The curved surface area is pi r L. And what is my L? L is my 10. And because they would want us to live in terms of pi, meaning we do not key in the pi in the calculator. So for this pi 6 square, we have 36 pi. And at this side here, how many pi do we have? We have 6 times 10, 60 pi. So total, how many pi? There is 36 and there is 60. Total, there is 96 pi. Alright. And for the last part, we are going to melt this chocolate and mold it into a cylindrical prism. Okay. So the very first thing to remember or to take note is that for this case, the volume remains the same. Yep. So we can tap on this to find the radius of this new cylinder. This means that the volume of this chocolate, we will need to then find it, yeah? So if it is in the shape of a cone, it will be 1/3 times the base area, which is a circle, pi 6 square, times the height, 8. But because this is not the final answer, I would actually live in terms of pi. So I will have 1/3 times 6 square times 8. I will get 96 pi as the volume. And this volume happens to be the same volume for this cylindrical chocolate shape, radius, big R probably, and the height is 3 cm. So the next thing to remember and take note is that for volume of a prism is actually base area times height. So I got the height already. height is 3. I also got the base area. But the base area is in the form of a circle, right? So it's pi r square times 3. Right? So it's actually 3 pi r square. And volume remains the same. So this volume and this volume are the same. Therefore, 3 pi r square and 96 pi are the same. They are equal. So I just need to divide by 3 pi on both sides. And finally, since this one probably I will just hide it away. And therefore my r is square root 32. Five 5.65685. 6 significant figures followed by 3 sig fig, 5.66 cm. Well, with that, we have come to the end of this particular problem video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.